Hi everybody, my name is Jimmy Carroll. I'm the Vice President of Operations at Tech B2B Marketing, and welcome to this episode of the Manufacturing Matters podcast, where we discuss the latest trends and technologies reshaping the manufacturing industry today. I have the pleasure of being joined today by Vikas Enti, the CEO and founder of Reframe Systems, and we're live at Reframe Systems. And first, thank you so much for having us here. Really appreciate it, and it's great to be here.
Wonderful to host you guys here. Thank you so much for making it out here.
Of course, yeah. So for those who don't know, please tell us a little bit about Reframe.
Yeah, so Reframe Systems, we're on a mission to build climate-resilient homes for all. Everyone's experienced this today where our homes have become extremely out of reach. The cost of construction's doubled in the last decade. And unfortunately, we don't have the skilled trades available to build them anymore. So combined with the labor shortage, we also see a challenge here where our climate and the events of severe are getting significantly more severe. So how do we start designing products that are not only low carbon in how they use energy and how they're produced, but are also more resilient to the changing weather patterns? Mm-hmm. And how do we do that in a way where we're significantly driving the hard cost of construction down, driving down the time it takes to build these structures, but also how do you make it super predictable? And that's Reframe in a nutshell is trying to make.
I've got a lot of follow-up questions that I'm going to get into, but I first want to ask, you used to be the former head of product at Amazon Robotics, right? Did I have that right?
That's right.
This is a shift, obviously. So what inspired you? What led you to want to do this?
The short version is I became a dad of beautiful twin girls, and I think I was starting to subscribe to this life philosophy on how do you start living your life so that when your kids are teenagers, they look back and they're proud of what you've done. And that was a whole mental shift, and I think that gave me the clarity I needed to say, okay, what are things I could be doing now? Like I spent the last decade up to that point making same-day shipping a reality for all, deployed over 500,000 robots across Amazon's network. We did a phenomenal job in giving people time back to actually have efficiency. And then the question became, okay, I've done a lot of work in giving time back. Are there things I could be doing to potentially change the mass equation, right? We've been emitting carbon significantly more than we should be. Mm-hmm. Climate change was top of mind for a while. That point kind of catalyzed it even more where I knew my daughters are going to be 19 and 29 and 2040 and 2050. What is the world going to look like at that point? Are there things I could be doing with the skill sets I'd built up over time to make a change?
Yep.
That search took about a year, and Reframe kind of came out of that.
No, I love that. Like there's so many websites, so many companies today that you go to their website and you read their about us, and they have this sort of philanthropic idea of we do this to better humanity, but you're actually trying to do that, and I really love that. All right, so I've got a number of questions that I want to ask. So from like start to finish, right? So how does it start? If somebody buys a house from you, what's that process look like from start to finish, and how long does that take?
It's a really good question, and I think it helps also contrast what the experience is today. If you're trying to buy a house, you're either buying a home that's already pre-built by a home builder, or if you're a developer, you're actually working with a GC or an architect to specify, right, like what types of products what types of homes or buildings should be built on this parcel of land. How do you maximize entitlement and then drive value? Reframe's taking a highly productized approach on how we think about homes and buildings as products. So today we have a duplex product type, which could be a single family for certain lots. Then we've truly taken the New England triple-decker, modernized it, and we have a triple-decker product. And then in the future, we're also going to have these small garden-style multifamily buildings. So the experience here, like our customers today are developers. So we're working with developers to make sure that they can go from empty piece of land to a building showing up as quickly as possible. Mm-hmm. And the overall process is also very productized where they're coming to us with the notion of, I want to get a triple decker on this site. And our goal is to be able to go from contract signing to permit submission in less than 30 days. Permits are not in our control today, but once we have permits issued, we're able to go from site work and foundation build to an occupiable structure in as little as 30 days. The very first project we did was up in Arlington, was a small 2-story single-family home. It was zoned as an ADU. We actually went from demolishing an existing garage that was on site to having an occupiable structure in 48 days. And that was the very first time we did it. We see pathways to go under 30 days highly repeatably. And obviously it has significant benefits to the developer from a financing standpoint, use of cash, etc. But there's also a huge benefit to neighbors and the whole construction process. Like our whole process where we build up to 85% of the work's actually happening in our factory, the factory we're in right now. We're taking all the noise and the dust and all the truck traffic away from the job site. So we're actually able to be really good neighbors. The noisiest thing, as an example, for our first project, we thought the crane was going to be the noisy thing. It was actually the food truck we brought on over. Because the generator of the food truck was the noisiest thing on that job site.
Right.
So we believe we're also able to change the nature of construction and make it clean and quiet.
Yeah, that's a noise worth having, I suppose,
Yeah.
right? I want to ask a little bit about the technologies, right? We're standing right in front of a fairly heavy-duty Escala robot and a really nice 3D camera, along with a lot of other underlying components that make it all work, right? AI is a topic that gets talked about quite a
Right.
bit, obviously, in the general public and in the technology space. So I've got a few questions for you on AI. One of them is this idea of physical AI, right? So I've seen this term physical AI thrown out a little bit more, and I have a sense of, NVIDIA. I don't know if they coined it or not, but I know that what they mean by it, and I have an idea in my head of what it means. But what does it mean to you, and how can physical AI be applied to building these homes?
Absolutely. I think physical AI has been a really good way to think about the next evolution of how do you go from robots that are learning, but still require a lot of human input to design those systems, to a world where we're actually able to have software that's self-learning, self-creating, to impact change on the physical world. But the prerequisite for all of these things is the quality of data that goes in, right?
Right.
So in our world, like we're already at the cutting edge of robotics today. We're using really advanced algorithms on our vision-guided system, so we can use number 2 grade lumber we can buy from Home Depot and still build some really high-performance structures. But there's no magical algorithm we can use today that's going to make things go faster. We actually have to start building the data set that's actually relevant to our industry. And where we see promise is at the pace at which algorithms are evolving, especially how we think about motion planning for a robot that's right behind me, to how we would actually think about the overall process of even designing a home and actually having it run checks against permitting or zoning, be able to automatically create permit sets and construction documents. There's like a whole set of tasks that take place in designing a home and manufacturing a home that we see significant opportunity for advanced algorithms to be part of it. They may or may not take the flavor of generative AI or transformers, but what we're finding is that the amount of data that's available and the way you actually catalog it is making it useful for algorithms to catch up. Where we are in our stage today as a business, we believe that we've set ourselves up for providing the right data and context for these algorithms to be successful. Today, even the way we use our robots, we're actually not pre-programming the paths. Like our robots are actually learning the motion profiles they have to execute. So if it's them picking an 8-foot section of 2x4 lumber, or if they have to put up a 16-foot section of lumber, they're actually able to recompute their motion plans on the fly to do that, which is very different than how robotic arms have been used traditionally. And this is the world we would call it a software-defined manufacturing, where we're taking all the traditional limitations that come with automation, where you're actually dependent on singulated feet of material, you're actually dependent on light sensors triggering, right, a whole bunch of signal inputs for your automation. We've moved into a world where we're all using vision systems to kind of get away from simulated processing to bulk processing of material, allowing the systems to actually make decisions on the fly. We've already made that step change. I think this is the world a lot of us are living in today. Where this gets significantly better over time is now I could have different models of robots that are not as similar to the one that's standing behind me, but they're all able to share the same model set. So as an example, I might have a miniature version of this robot that's on a mobile platform that's actually able to go and do drywall sanding and painting, but it already has all the context and all the models that we've trained it on for getting a fixed robot working. So we see a world where not only do we get to a scenario where harder tasks that require more dexterity, more reasoning are getting easier to be performed, but we also get to a path where the engineering effort needed to build and design these systems are also going to be significantly shorter time cycles. We actually get to build these systems a lot faster than we could before. And that's what keeps us super excited about this future. But I do want to highlight that it all starts with the quality of the data that you have.
Of course.
And today we're really mindful to make sure that we're kind of setting the right infrastructure to capture all the data that's relevant on the designing of the buildings, translating those instructions into manufacturing instructions, all the way to exactly how the robot's doing its tasks out here.
So I just have several follow-up questions. One of them that I want to ask though is, how, if at all, does simulation come into play? Digital twins, when it comes to like maybe let me just stop there.
It's a prerequisite.
Yeah.
So today for us, at a macro business level, the whole act of trying to build a home in a factory requires you to get to a high level of modeling. where the home is modeled to a level where every single fastener and fixture, light switch is already modeled in it. We're modeling the exact routes the wires and the products like your plumbing has to take. So in a way, we're building the most accurate digital twin of the end product, which is atypical for construction. We have to do it as a prerequisite to make our entire process work. But then if you go a step back, it's like, what do we have to do to make our underlying automation systems work? At the factory level today, we have digital twins existing at the work cell level. So even this robot, we took possession of it in, I believe it was August 2023. And by that point, we had about 5 months of time before we took possession of the robot, where we actually ran full simulation models of this robot to make sure we got all the motion profiles figured out. How do we design the full range of motion that's needed to get this jiggy design behind it? So we got a lot of work done in simulation to a high level of fidelity that by the time we took physical possession of the robot, we could go from robot getting powered on to robot actually executing its first set of tests in less than 3 weeks. And the robot that's behind the camera here took us about 3 months to install. For folks who can't see it, it's the same Yaskawa robot behind me, but on a linear rail that can build wall sections of 16 feet or longer. We were able to commission that in less than 3 months to go from hardware install to full production because we could run through all of these iterations in our simulation platform, iron out all the kinks that exist, and how do you add a 7th degree of freedom for mobility, which is a whole layer of complexity that we've added to the system. But we could actually de-risk all of that in simulation. And I think we're finally getting to a world where you can actually get true digital twins, where you're actually able to keep your physical environment in sync with the digital environment. And we're pretty excited to see what that looks like as the platforms become more robust.
Yeah, so it feels to me, and correct me if I'm wrong, you'd be the expert here, but it feels to me in the last, 4 or 5 years, I'd say, that there's kind of been an explosion. Maybe not an explosion, but let me back up. 7 or 8 years ago, maybe even a little bit longer, AI kind of burst onto the scene in the industrial space, specifically deep learning, and it was being overhyped. And I talk about this often, but it's interesting because I always like to get other people's perspective on it. Is at first it was being touted as this magic tool. It's going to solve everything. It's going to replace traditional discrete rules-based algorithms and things like that. But it seems as though in the last few years, it's really settled in and found really a number of novel and interesting ways to either be an enabling or complementary technology to existing automation. And in some part, it feels like that's because of some significant advances that have been made in things like industrial computing and GPUs and simulation environments. Would you agree with that?
Absolutely. I think a bunch of things have happened at, say, circa 2016 onwards. I think deep learning as an aspect for training algorithms, especially on vision systems, has allowed us to do some really insanely good things really, really quickly, where now we're actually able to allow arms to do vision-based picks significantly faster than the way we could do that with computational solutions before. And I think that's been a huge advantage. What's also come along really far in the same time period is the way all the systems that have come along for us to be able to capture images, catalog it, label them so that we can actually retrain algorithms quickly. These processes just become bread and butter today that every college graduate's coming out learning these skills very quickly. But for engineers back in the 2015, 2016 era having to translate from traditional automation techniques to using these algorithms, it was a huge step change. We got to see this live even at Amazon, where we went from, we were trying to really realize the future of like robotic picking. There was on the Amazon picking challenge where it would take teams, like several minutes to make a pick, and that would be for like a very small subset of items. And 5 years since then, I think we've gotten to a stage where we can pick millions of different items in seconds, and a lot of that has had to do with the fact that the actual algorithms and the whole deep learning data sets that have been available are really pushing us to the forefront.
So okay, cool. That's an interesting answer because I want to ask a little bit more about AI, but maybe in a different context. Two things. One is, I have to ask this, like when you're meeting somebody like, I don't know how old your daughters are, but if you're meeting their parents or somebody from the first time that's sort of outside of your industry, and you explain to them that you deal in robotics and AI, do you ever see any fear? And how do you dispel the notion that people should be afraid of AI? Because I think it's the opposite, right? Like what you're trying to do here specifically is trying to help humanity and not destroy it, like the movies tell you.
Yeah, I think my whole mental model of robotics, software, learning algorithms, AI, these are all tools in our toolkit to solve really hard problems.
Yeah.
And I mean, it's understandable given what Hollywood's done for people to be really, really scared about all the bad things that could happen if the tool was misused. But that is true for even a stapler that you have, right? You could always misuse a stapler and do bad things with it.
Fair.
But I think as it comes to people's perception, I think there's also there's a certain level of risk and threats that are coming up when you think about the military use of robotics and drones, and especially with threat actors that are not necessarily friendly to the US as an example, right? Like those threats are real. But if you kind of think about it from just an industry standpoint, right? Like, should you be concerned about having a robot in your home? I've had a Roomba in my home for the longest time. It's been a cute little equivalent of a pet, if not for anything else.
Yeah.
I think we're finally going to see a future where we're going to see more of these technologies available for general industrial use, general home use. I think it's upon us as companies using these tools to design solutions that are safe, well understood, and well communicated. And a lot of that is intent. We've spent a lot of time thinking about, like in our case today at least, we're working within an industrial setting where our robots don't have to work alongside people, right? So at least the intent clarification is very straightforward. But we're going to enter a new future where we're going to have a lot more collaborative robots, a lot more interplay between robotic systems or just sensor-based AI systems that are working alongside people. I think there's going to be a huge portion of user experience design that has to come in there for how do you actually let people understand the intent so they're not surprised if an odd behavior takes place there. But I'm an optimist by nature. My general view of the world is we all have the right intents here. We have to start designing the right mechanisms to make sure that bad, unsafe things cannot happen. And in terms of the intent of use, I think it's upon us as a society to make sure we're furthering and incentivizing the right intent versus the harmful intent.
That's a really good way of looking at it. I talk to a lot of people, and I've had this ongoing conversation for years now with my in-laws, and they ask me all these questions about what is it exactly that you do, and tell me more about the industry, and tell me why I shouldn't be afraid of robots, and explain to me how robots aren't actually taking jobs, they're creating them, and then we talk about things like AI, and then, in fact, I told my father-in-law yesterday that I was coming here, and I said, you know, Reframe is a company that designs microfactories, robotic microfactories that build sustainable homes. Hopefully I nailed that short description.
That was amazing, thank you.
Thanks, yeah. And he said, well, why are they doing that? They're taking away the jobs of people. I said, well, not really, but I'm gonna ask them about that tomorrow. So I guess I'd like to ask you about that. And then part two of that question, I guess, would be, well, I'll stop there and I'll wait.
Yeah, it's, I mean, like I said, the robot's a tool for us. All of these are tools for us to solve the problem for how do we make sustainable housing highly attainable. And the reality of the situation today is, even the reason we need a factory is to have a more efficient process that allows us to increase labor productivity. Construction in the US today has about a 500,000 worker shortage, and these are all the skilled trades. And the compounding effect to that is about 40% of the trades are aging out. They're set to retire in the next 10 years. Mm-hmm. And we've already seen the impact of cost and the pace at which we can build over the last decade because of the lack of workers and the lack of project costs making sense. The fact that we don't have starter homes anymore, a lot of it has to do with that. You can't do brand new construction for less than $400,000 for a home. So when you're actually undertaking a project, you just have to build $1 million home instead to make the cost pencil, right? So I think, so the problem here is how do you make construction more repeatable, fast, and cost efficient? We believe the biggest lever available to do that today is to improve labor productivity. And to improve labor productivity, we've taken two approaches. We have a lot of software we're working on, which allows us to give apprentices superpowers. So if you walk around our factory, you'll actually see we have a bunch of high school students who are doing a co-op here, all the way to new carpenter apprentices who are all working off of iPads, which tells them exactly the information they need. Their instructions look more like Lego assembly instructions versus construction shop drawings, to the fact that they're 70% faster in performing their tasks. So we're employing people at a much higher wage rate, and we're able to make them perform more so that we can actually produce more homes and solve one piece of the problem. The other piece of the pie is that there's a whole bunch of tasks in construction that were a necessity that are not really enjoyable. So when we polled our carpenters earlier too, like, to them, a lot of the pride they took in the job was like, let's work on things that we actually get to see right? So the finishry, the craftsmanship they can show off with finish trim, cabinetry, etc. All this stuff that happens inside a wall, you're like, hey, like it's a very repetitive process. We're fine if that goes away and if it magically gets taken care of.
Yeah.
And we said that's a great requirement for our automation team to say, can we robotically frame a home and kind of take the dull repetitive task of framing away while we can actually use the people we can hire to focus on more of the finished tasks and finished trims. And that's where we kind of feel that the robot's still a tool in our arsenal for how do we make sure we can drive the overall productivity of labor up, in return produce more homes with the same number of people so we can drive the effective cost of homes down. And I think like this is a construct that is very hard for human nature to act, like it doesn't pass human intuition very quickly because you're like, because it's very tempting to think about everything being scarce, right? Like it's scarcity is what triumphs our initial thinking versus abundance. And it's human nature to always assume that everything is limited. So if you're taking some portion, if you're automating certain parts of roles, it's first instinct to assume that you're actually taking work away from an individual. The reality here, and the reality this actually also makes economic sense, is that there is better, more higher value work for those individuals to be performing, to the point that robots and automation in general, this has been true for the last 20, 30 years, they're taking away of all the tasks that are really hard for people to do, really dull or really dangerous.
Yes.
And I think that algorithm is going to continue for a very, very long time.
Yeah.
Let me pause there. I know you had follow-up questions on it.
Yeah, what I wanted to ask was, first of all, I told him not as eloquent and detailed as that, but I said, well, they've got builders and construction workers that work there alongside. It's not just a factory of robots doing these things with a faceless company. But the other thing I said was, and I have to admit that I got this from your website or maybe your LinkedIn or something, but it said, hey, like home building is a trade that hasn't really innovated much in the last 100 years. So like, is that part of your intent here too? Is to say, hey, like we're not just going to try and build something. If you build it, they will come. We're trying to solve a specific problem, make things easier, more efficient, and kind of take home building into the robotic age.
You're right that home building and construction as an industry, while they've had significant innovation, adoption of innovation on the software side of things, right, the way we design buildings, the way we actually look for interface checks with BIM, et cetera, there's been significant progress there. But when it comes to the physical act of building stuff, like that's an area where power tools were the first huge step change that took place. Beyond that, I think we've had a lot of micro innovations that have taken place, but the industry as a whole hasn't been able to adopt and make a significant improvement in productivity. A big piece of that is just how fragmented the industry is. If you think about automotive or almost every other industry that's either building appliances or building chemical products or cars, the size of the company relative to the product actually makes a lot of sense, right? You could think of an automaker. You have maybe 10 large automakers in the world that are building most of the cars. They kind of own most of the market. That allows them to capture enough capital and resources to actually then put resources against R&D. If you think about home building and construction, there's 50,000 home builders in the US. The top 10 actually build almost, I forget the exact stat, it's like close to 40% of all homes. But then you have small teams of, like 5-person home builders that are then fragmented across the industry. So no single entity actually has enough resources to consult and say, we're going to come up with a better way to actually build it. And unfortunately, that's become the way things have gotten done over time, where the best construction companies are ones that own the least amount of assets, that actually have the least amount of overhead, so they can spin up teams quickly to deliver project and spin back down. So what this has done is built the most efficient project execution functions in construction, but not the best R&D functions, which require much longer time horizon thinking, much different investment cycles. And I feel like that's where it's been a very interesting trade-off for the industry to make. And this is where we see an opportunity for us as outsiders coming in, right? Like we have some of the naivety that comes in to say, we think we actually have a shot at doing this slightly differently in the approach, but actually drive step change outcomes. Like we're not coming in to say we have to just fundamentally rethink everything end to end. What we found is that a lot of the inputs are great. We actually believe the Lightwood framing system is actually really incredibly efficient system for how we use material. And we said, let's not change that. Let's just figure out how to use existing materials, but more efficiently. How do we apply better techniques for how we use them? And then use software to make sure we're taking waste out of every single step of the way. So what we're actually doing still here is back to what we did at Amazon, is we're taking time out. We're taking time out of every single step of the process to go from selling a project to designing a project to manufacturing to installing. And that's where we drive efficiencies. And the only way to take time out is to bring technology in, and here we are.
I like that. It's really well put. I want to ask a little bit more about the sustainability factor here, and as somebody with your background and knowledge of automation technologies, what are some ways that you are either seeing or could see robots and AI and machine vision technologies, motion control, all the others, I don't want to single out just those, leading to a more healthy, greener Earth?
Absolutely. The good news is we're already seeing a foray in many different domains, right? Like we're trying to do this in home building. The reason we can build more sustainable homes is one, we get the factory precision, which allows us to build homes that are significantly more airtight, but also the arbitrage we have here where we're being more productive on the labor side, which allows me now to use higher quality materials that have lower embodied carbon, that allow us to still achieve similar cost parameters and make a project pencil, but with a much better carbon story behind it. So that's been a place where automation is allowing us to, again, take time out, but just take cost out to use better materials. We've seen other industries. I think the most notable one, which we'll all feel a benefit for, I would say, is on the recycling and trash sortation industry, right? We're finally seeing the advent of robotic arms and vision systems that can sort trash or sort your mixed recyclables to make sure we actually have higher yield. And I think the more we can do that, like trying to have every individual take a practice where they're making choices that can actually compound to become more efficient is a really hard user behavior to change. We've learned that time and again. But if we can use technology, it allows us to be bolted on to end waste streams as an example where we don't have to change user behavior necessarily. We should try. That's a hard thing to change. But if the cost and the time to actually sort through stuff in this case goes to zero because we actually have automation techniques. And there's one example where we can truly find a pathway to reuse material as much as we can. And I think the same applies if you kind of look at the stack up of all the other industries where carbon emissions are incredibly high, right? Like we gravitated to the built environment because our homes are emitting more carbon than our cars, and we found a clear path to apply our background and techniques in here along with my co-founders. But if it was in home building, I'd be in agriculture. That's the other industry where the whole practices we have with agriculture today, with industrial farming, has really got into a scale where our soil isn't able to actually absorb as much more carbon to it. The amount of fertilizer use actually drives a second order cycle of carbon emissions and energy use that I believe is actually, and anyone else who's out there happy to talk about this, there's a whole use case for regenerative agriculture where we can make the process of farming at an industrial scale significantly more efficient, but that requires us to rethink the entire process of what does a tractor need to look like to actually scale this up. And I think that's again a place where, right, not just industrial arms, but mobile robots, right, the whole gamut, the entire technology stack we've developed for manufacturing becomes very handy to the industry.
Those are really, really good examples, and they're ones that I write a lot about, I talk a lot about, I read a lot about, and one is recycling, and hyperspectral imaging used to be a technology that was kind of complex, costly, large, kind of limited to the lab, but now you have cameras that are, some of them are really this big, that can be used to even recycle just black plastics. And then in agriculture, for me, like seeing a system like this or any other demo or actual, this is not a demo, the convergence of different advancing technologies, I think agriculture is a really good one, right? Because there is, there's been a lot of advancements in SWIR and multispectral imaging, but there's also, like you're saying, like, knowing where to water the crops. Like, you can capture these images on smaller, less expensive multispectral or SWIR cameras, and then you can use AI to say, all right, well, this part of the crop has been overwatered. We need to, or needs more seed or whatever. Where I'm driving. So I just think it's really cool to see applications where there's like a lot of different technologies coming together to solve problems, and you're seeing these latest advances. Like you've got a newer 3D camera in here, and then you've got a robot, but then you're using AI, and these are three of the technologies that are most interesting and talked about today. And I'm glad to hear you say it.
Absolutely, I think the world is bright.
Yeah. On that note, right? What are some technologies that in the general space that you're excited about? Anything that we haven't talked about? I mean, we've kind of talked about a lot at this point, but
I think we've covered a bunch of it. Like, I think to me, the biggest unlock, I'd say, is on the entire spectrum of vision sensors, right? So you mentioned, right, different frequencies for different use cases. I think just the fact that the cost of imaging sensors have gone down significantly, the deep learning algorithms allow you to actually get useful information out of it has also increased in performance, right, a few orders of magnitude over the last couple of years. I think we're finally getting to a world where, like, a lot of our work on making systems that were smart were really based on finding all these other workarounds to make sure we could replicate how a person or how a vision system would actually, right, recognize the world, right? Everything from trying to simulation, as an example. Like, all of manufacturing today, anytime there's automation, you're trying to simulate a component to a fixed location for a robot to then pick it from that fixed location blindly and place it. That's how we've done it for the last couple of decades, and that's what's resulted in, right, like, massive manufacturing facilities just because the space utilization is awful. What gets us excited about vision systems are everything from the cameras on your phone, right, all the way to simple webcams that we have for surveilling the facility. They're all getting to a quality of visual information capture that are useful for us to train algorithms, to the point that I think we will truly get to this step change in the industry where we're moving away from singulated information processing and material processing to bulk processing, where all of a sudden all these sensors and conveyor systems and indexing systems that were the backbone of the industry, right, like, sort of become less relevant and less necessary, which I think will again translate to automation actually becoming more attainable for manufacturers, right? If you think about the old understanding, you'd say, hey, automation never makes sense for a small facility because you can never keep it utilized. That made sense if automation, like a work cell like the one I'm standing in, costs you a few $1 million. You'd be like, great. Would never make sense in a small system. But we'll be able to scale the cost down to $150,000 for this work cell, where it's equivalent at the rate of framing for 2 carpenters coming in. The reason we could do that is our vision systems actually allow us to get away from the need for simulation. All we can do is roll in a cart full of lumber, the robot recognizes the studs, picks it up, frames it. Like, that step change was impossible to think about 5 years ago, and now it's just expected, right?
Yeah.
I think we're starting to see that progress, and to me, I think everything that's built off of vision as a starting point gets us really excited here at Reframe. We believe that's the backbone for most AI work that has to take. But obviously, LLMs have taken all the attention lately.
Yeah.
But I think where we start seeing the stepfold increase is, like, understanding vision, and sensors have gotten attainable, and I think algorithms will also get significantly more attainable.
I was going to close it out in a minute, but I have to ask another question just because you brought it up. Like, automation is becoming more attainable. It's becoming easier to use, and ease of use is a term that gets thrown out a lot, but maybe that's obvious, but things are becoming easier to use.
Right.
Like, where a non-machine vision or non-engineer can operate a robot and troubleshoot it oftentimes. Right. Do you see, because you mentioned it earlier, right? You mentioned cobots, and do you see cobots as being like a primary pathway for small and medium-sized enterprises to be able to adopt automation?
Absolutely. I think the number of opportunities for, right, simple machine tending applications all the way through, I feel like there's a whole bunch of applications that the industry hasn't quite figured out a solution for. But if you start treating the cobot as a tool set that a manufacturer can then use and figure out how they would use it, I think it starts changing the paradigm completely, right? So I think we're seeing some really encouraging, right, like, software systems, training systems, and the whole cobot package coming together that actually allows end users to figure out how they would use it. And I think that's going to be a huge unlock for more solutions that an outsider wouldn't be able to figure out versus someone who's living it day in, day out.
Yeah, it seems to be the pathway for me. I just always like to ask people who are smarter than me if they agree with me, and I'm glad that you do.
I mean, doubt I'm smarter, but definitely agree with the observation. I think cobots and I think more accessible automation techniques is the key for the U.S. to reshore manufacturing in here.
Yep.
There's no other way for us to compete.
Anything else that we haven't talked about that you feel like you want to mention? And obviously we can let people know how to find more information, but if there's any other, general bit of information you want to put out there, please do.
No, thank you. I'd say the mission we're after, Reframe, means dear to us. I think it's a very personal mission, and we're finding a lot of partners, be it customers, our employees, potential stakeholders coming in to join it. So we feel very fortunate there. Yeah, we love the opportunity. Selfishly, like if you're looking to build a home or buy a home, come talk to us. And the other thing I'd say, I actually thought you were going to be asking me about humanoids. Like that's a question I get asked a lot. And I might as well address it now in case someone's thinking about what happens when humanoids become real and you're actually able to use them. We welcome that day when we see different forms of automation that are more capable. The reality today is a humanoid, or at least most that are being advertised or on the market or have attention, can't even lift a nail gun, right? They don't have the capacity to do it. So I think we still have a long ways to go before they're actually capable in industrial environment. Industrial arms aren't going away anytime soon. We should just view these as complementary tools on the tool stack.
Yeah, and I'm glad that you did ask about humanoids. I did mean to ask you about it, and yeah, I caught a headline from the NVIDIA GTC conference that Jensen Huang said that humanoids are closer than people think. I didn't read the full article, but I'm curious to see in what capacity, right? Yeah. If it's walking a trade show booth and handing out business cards, yeah, for sure. But yeah, working in a factory, you know, we'll see, right?
Yeah, I mean, there's absolutely a bunch of, I'd say, highly repetitive, low payload applications, right? Having come from the e-commerce world, there's a whole bunch of tasks in there that you could see a humanoid with the right payload capabilities be able to handle it. I still think there are more fundamental issues to be solved here in terms of, right, like what is the battery capacity on these robots, right? Like, are these going to be like the early drones where you had 10 minutes of flight time and you had to recharge stuff?
Yeah.
I think there's a whole bunch of engineering that has to be solved. There's merit to solving these. We think there's a future to it.
But the other thing too is that I think about and I've heard talked about is why a humanoid and not just a wheeled robot with arms. Like that's what I'm looking forward to learning more about and seeing. Obviously, I want to see these humanoids. I want them to succeed. But those are the robots that people are most scared about. So we'll see how the general public reacts to that. But like you said, it might be a little bit far away. There's not too many of them yet. Although, did you see the recent video of Boston Dynamics Atlas robot moving around doing breakdancing moves, and it's pretty impressive.
It is. It's always fun to watch their videos, and I think it's a matter of time before we can find useful applications for them in scenarios where you're able to perform a set of applications. Like I'd say, like one thing that's really important to distinguish here with the new class of robots that are coming up, a lot of the work we've been doing in manufacturing and industrial automation were usually a robot to perform a specialized task in a specialized controlled environment. But that's where you start incurring all the second order costs that are involved in the amount of space it takes, have you got to cordon off stuff. If you could have automation systems that can coexist and work alongside people, but also perform a set of tasks versus a single task with the same hardware that's on that robot or that automation system, that would be the superior solution over time. And I could see how one such bet is a humanoid or arms on a mobile platform gets us closer to the reality where you can perform a set of tasks versus a specialized task. And I think we should all be welcoming that because it's going to make industrialization a lot more efficient. But the reality check for today, though, I think is there is still a lot of hardening that has to happen. The capabilities of these systems also have to increase to take on a broad range of industrial applications, right? So the capability might be getting there sooner than we expect. We're taking a more cautionary note here in that there's still going to be a long tail of edge cases that have to be solved before you see a humanoid in every factory or every use case. But there are definitely use cases in our factory here that where we would welcome right, partnering with the manufacturer that has the right payload capacities on their systems for us to go take on a set of applications that our software can control and kind of move that forward.
Sure. Yeah, no, I'm looking forward to it too. I am. It's very exciting. Before I close out, tell people what's the URL to your website if they want to go learn more.
Yeah, check us out on reframe.systems or reframesystems.com, whatever your preference is. And there's plenty of information there.
Yeah, and if anybody has any questions for Vikas or for myself, manufacturing-matters.com would be happy to pass those along, or if you'd like to send in any comments or join the podcast, please do. Otherwise, thanks for either listening or watching.